Hari Om. Now let us proceed to the topic electrical resistance. This is a very familiar topic to you all because you have already read about this in class 10th. So you won't be facing much difficulties here. We will proceed fast. So what is resistance? It is the opposition offered to the flow of current in a conductor. So the amount of opposition that is being applied or that is being offered to the flow of current in a conductor is called as electrical resistance, and we denote it by the symbol capital R. Its SI unit is ohms, given by the symbol ohm. So the SI unit is ohm. Now let us find the dimension of resistance. As R is equal to V by I from Ohm's law, so the dimension of R will be dimension of V by dimension of I. Now if you remember, there was a formula that is V is equal to W by Q. Potential difference is equal to work done by the charge. So V is equal to W by Q. So the dimension of V will be dimension of W by dimension of Q. So the dimension of R becomes dimension of W by dimension of Q dimension of I. Now dimension of W, that is work done, its dimension is M1 L2 T minus 2, and dimension of Q, if you remember, there was a formula current is equal to charge by time. So charge will be current into time. So Q will be current I into T. So dimension of Q will become dimension of I into dimension of T into we have another I. So this will become dimension of I square into dimension of T. Dimension of I is represented by A, that is ampere. So the denominator becomes dimension of I square T will become A square T. So after simplifying this, we get the dimension of resistance as M1 L2 T minus 3 A minus 2. Now let us come to the cause of resistance. Why there is resistance in conductors? It is because, as we have already discussed, conductors have free electrons. Conductors have abundant free electrons in them, which are constantly in motion with some velocity, that is thermal velocity. But if we apply a potential difference, then all these free electrons move in a single direction with drift velocity. Now when they are all moving in a single direction, or when they are moving itself, then they are constantly colliding with each other. They are constantly colliding with each other. This collision is what prevents them from moving freely, and this collision between the free electrons is the cause, is the main root of resistance. Think, if you increase the temperature of the conductor, the free electrons will move more randomly with more velocity. Now when they are moving with higher velocity, they will collide even more. So resistance of a conductor increases with increase in temperature. Alright, now there is a law of length which is called as. Now let us come to combination of resistors. This topic also you have read in your class 10th, that is series combination and parallel combination. You must have solved many questions related to that also. Just let us revise a bit. In case of series combination, the current that flows through each resistor remains same. So the amount of current is going to be same, but the potential difference across R1 plus potential difference across R2 is the net potential difference, that is V. This is what you have to remember here. So V is equal to V1 plus V2. Now you know that V is equal to IR from Ohm's law. So V1 will be I R1 and V2 will be I R2. Now let us consider that instead of R1 and R2 we are using a net resistance, that is R net, through which the same current I is flowing. So V will be equal to I into R net. Now let us compare both the equations 1 and 2. So if you compare them, you are going to get I R net is equal to I R1 plus I R2. If you take I common from the RHS and cancel it with the I of LHS, so R net will be equal to R1 plus R2. In place of 2 resistors, if we have n resistors in series, then the net resistance will be just the sum of all the n resistors. Now let us proceed to parallel combination. In case of parallel combination, the potential difference of all the resistors is same. In case of series combination, the current flowing through them was same. Here the current gets divided, but the potential difference across all the resistors is same. So suppose initially I current was flowing, and at the junction it got divided into I1, I2 and I3, which after passing through the resistors again combine to give us the value I. So from Ohm's law you know that V is equal to IR, so I will be equal to V by R. Now since I1 is flowing through the resistor R1, we can say that I1 will be equal to V by R1. Similarly I2 will be equal to V by R2, I3 will be V by R3. V remains same because the potential difference across all the 3 resistors is the same. Now if you can see, I1, I2 and I3 will add up to give us I again. So we can write I is equal to I1 plus I2 plus I3. Now just put the values in the equation. So I will become V by R1 plus V by R2 plus V by R3. Now suppose we replace the 3 parallel resistors with a net resistance, that is R net, with where current I is flowing through it. So here I will be V by resistance, that is R net. So I will be equal to V by R net. Now if we compare these two equations, we are going to get the result of parallel combination. So V by R net will be equal to V by R1 plus V by R2 plus V by R3. Now take V common from the RHS and cancel it with the V of LHS. So our 1 by R net will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. So if we have n resistors in parallel, then the inverse of net resistance, that is 1 by R net, will be 1 by R1 plus 1 by R2 plus 1 by R3 till 1 by Rn. Now suppose all the resistors have same value, that is R. If there are n equal resistors and suppose they are combined in series, then the net resistance will be R1 plus R2 till Rn, but the value of all the resistors is R. So you have to add R n times. So you are going to get NR. So the net resistance will be NR. But if those n resistors are in parallel, then the 1 by R net will be equal to 1 by R1 till 1 by Rn, and 1 by R1 will become 1 by R, 1 by R2 will also become 1 by R. Similarly, you are going to add 1 by R n times. So the inverse of net resistance will be N by R, or the net resistance is going to be R by N. So if you are adding resistors in parallel, you are going to decrease the value of the combination of the resistors, and if you are going to add resistors in series, you are going to increase the resistance. Alright, so with this, let us stop here today. We will proceed to the next part in the next video. Thank you.